Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, again, we're gonna look at alternative method. This is gonna be the last time that I do videos. I rather record videos without using any alternative formulas and come back with another video. So I know for some of you it's gonna be frustrating, but please bear with me for those who want to understand all these formulas. All right. So now let's look closely to this. Now I want us to look at 5.2 where we were required to calculate the speed of the grate when it reaches point C. Now, if I remember very well, we used work W net is equal to change in K. Remember, I said this formula it is applicable everywhere. I get. So now I want us to look at an alternative method. Or we remember we can use what W work done by non-conservative force. It is equal to change in K plus change in what? Change in U. Now let's go back to our free body diagram. Now, on our free body diagram, remember we have three forces that are acting parallel. But not all those forces are non-conservative force. Remember, only friction and force applied or any external force is a what force of is an a conservative non-conservative force, whereas Fg, whether it is a component of Fg or what, it is a what it is a conservative force. This is a conservative force, this one, but this it is a non-conservative force. Also, this it is a non-conservative force. So it means when we go to our formula, we're gonna say work done by non-conservative force is gonna be work done by friction plus work done by force of the mode. It is equal to what? Change in K. Change in K, we know it is half mv squared final minus half squared initial plus what is mgh? Mgh, it is mgh final minus mgh initial. Now let's talk about height. In this information we were given what? In this information we were given change in x. Change in x. All right? This path here from A to C to D to whatever this point is, it is our change in x. But now, how do we find h? Remember, h it is a vertical height. From maybe here to here, it is height. From here to here, it is height. From this point to this point, it is height. This point to this point, height. But here we know our height is 0 at point A. At point A, our height it is 0. But now, according to the calculations that we have to do, we had to calculate the speed when it reaches point H. So it means rather point C. So it means we might need to find the height at point C, this height here. So we all agree, Hori, if I draw that height here, I'm having a right angle triangle here, where this is my 90 degrees. We all agree. Agree. So if that's the case, I know how to find what? Let me just say it here. H it is equal to 0. H at A. All right. Now, how to find H? Remember, this is my change in X, and I was given this is my change in X. My hypotenuse is my change in X. So I know this is going to be opposite. Let me just redo it here. This is going to be sine of 18 degrees. It's going to be opposite to my angle, it is height. What is my hypotenuse? My hypotenuse it is change in x, but I know change in x it is equal to how much? To 15.6. So it means when I want h, I'll just do cross multiply. It's going to be 15.6 sine of 18 degrees. We agree. Now this is the h that we're going to substitute at h final. All right. Here you're going to say h final, or just to be more precise, just say h at the end, h at C, because it is the final position, and h at A. All right. Even here you can say final velocity, or velocity at C and velocity at at A. However, it's fine, whichever you use, final, initial, or C at A. Now, this is the height at C. We agree? This is the height at C. So, if I substitute here, so before I substitute, I want you to realize something. I want you to realize something. Oh, even though, yeah, you'll see when I substitute. Ne? Please agree with me that my initial velocity here was 0. Velocity at A, it is 0. This is 0 meters. Again, so anything that has to do with A, I substituted 0. Why? I'm saying this one is going to be equal to 0. This is going to be equal to 0 because the velocity at 8 is 0. And this is going to be equal to 0 because the height at 8 is 0. So on my formulas, this will go off, this will go off. I'll be left with work done by friction, work done by force of the motor, half mv squared plus mghc. Now, what is work done by the friction? Was I given friction? Yes, I think friction and motor was A. Those I was given. What is, I'm going to say this is F changing X cosine of theta plus force of the motor changing X cosine of theta. It is equal to half mv squared at point C plus mgh at point C. Now let me try to substitute. What was my frictional force? I can remember very well. My frictional force was 13.5. Changing X was 15.6. Cos of an 8. Plus, force of the motor was 96.8. Just confirm 98.6, 96.8, 96.8. Then my change in X was 15.6 also, but now it is cosine of 0 degrees. It is equal to what? I'm going to continue underneath here. Substitute this side. My velocity, this one is going to be half. What was my mass? My mass was given to me as 20. Then what is my V at C is what I'm looking for. Plus my mass, it is 20. What is my gravitational acceleration? 9.8. What is my height? Remember my height was 15.6 sine of 18 degrees. Again, here it is here. Again, 15.6 sine of 18 degrees. Now, before we further on with the calculations, I want you to compare something and see how these formulas are the same. Ne? Let's look at our substitution. Force of the motor, substitution for force of the motor, here it is. It has 96.8, 15.6 cosine of 0, also here. 96.8 cosine or 15.6 cosine of 0. Let's look at the substitution of friction. Here we have 13.5, 15 multiplied by 15.6 cosine of 180. Also here we have the same thing, 13.5 cos of 180 multiplied by 15.6. Now, but rather in this case we had force of the work done by FG parallel. But in this case, instead of work done by FG parallel, we have MGC. But on the other side, I want you to see something. Look at the substitution here. Look at the substitution for MGC. It is 29.8, 20 multiplied by 9.8 multiplied by 15.6 sine 18. Look at this here. Look at this here. 20 multiplied by 9.8. Here it is. We agree 20 multiplied by 9.8. Also 15.6. 15.6 multiplied by sine 18. Here it is. Cos of 180 means this is negative on this side. This on this left hand side was negative. If we take this to the other side, it's going to be what? Positive. Hence here it is wrong. It is positive on this other side. If we were to take this one to that side, to the bottom substitution, remember this is left hand side, this is right hand side. If we were to take this to the left hand side, it was going to be negative. So you can see how these formulas actually are similar. These what formulas are similar. It's a matter of you understanding how to do what, how to apply them, and to calculate. Very important, or rather to be able to identify, or here we are using MGC, and we do not include force done by the parallel. We do not include here. Why? Because it is not a non-conservative force again. And here, like, it's a matter of you knowing the variables that you're gonna use when you substitute. Here, work done by the net force, you include all the forces. But here, it is work done by non-conservative force. You only include work done by the conservative what? Conservative forces only. I believe you're following. So that's all I wanted to explain, folks. Thank you very much. Until we meet again in the next video.